Hi everyone, welcome to this video of glycolysis. In the last video, we learned about the oxidation of glucose to pyruvate with the production of ATP molecules and NADH molecules. And we also learned about the various enzymes involved in the glycolytic pathway. In this video, we are going to focus on phosphofructokinase enzyme. So, this whole video is about enzyme induction, that how enzymes are able to control the glycolytic rates. So, enzyme induction. The mechanism for controlling glycolytic rate is transcriptional control of glycolytic enzymes. So, what they are trying to say here is the regulation of glycolytic rate, the whole glycolytic rate from glucose oxidation to pyruvate, this whole thing is able, we are able to control it by the expression of genes, by controlling the expression of genes that code for glycolytic enzymes. So, by controlling the enzymes, we are able to control the regulation of glycolytic rates. So, altering the concentration of key enzymes allows the cell to change and adapt to alterations in hormonal status. For example, what happens if we increase the level of glucose or we increase the level of insulin? It will increase the level of enzymes hexokinase, okay, and pyruvate kinase activity, therefore increasing the production of pyruvate. So this is how we are trying to achieve the regulation of glycolytic rate by controlling the glycolytic enzymes. Now phosphofructokinase. What phosphofructokinase does here is it can transform fructose 6 phosphate to fructose 2 6 bisphosphate. So PFK-2 is involved here. Phosphofructokinase 1, phosphofructokinase 2. So phosphofructokinase 2 is able to transform fructose 6 phosphate into fructose 2 6 bisphosphate. So what happens is the fructose 6 bisphosphate, it is actually an allosteric regulator of PFK-1. So by the production of fructose 2 6 bisphosphate, it will automatically increase the level of PFK-1. Okay. So what this the whole thing is about. So allosteric activator. Let me tell you about the allosteric activator. So there are enzymes. For example, this is an enzyme, and it has what it has is an active site for substrate. This has an active site. This is my substrate. For example, let me take a different color. This is my substrate. So this is an enzyme, active site, and substrate. So what allosteric activators are? Sometimes allosteric regulators means that there are some enzymes, what we can say that activators. For example, insulin. Okay. Or it could be anything like fructose 2 6 bisphosphate is acting as a allosteric regulator here for PFK-1. So what it will do is it will bind to the allosteric site, that enzymes have allosteric sites too, where allosteric regulators bind. And by binding at the site of allosteric site, they can either enhance the enzyme's activity or they can inhibit the enzyme's activity. So it depends on the what? It depends on the allosteric regulator. So this fructose 6,2,6 bisphosphate is actually activity of PFK-1. It is increasing it. So it is acting as an activator here. So this is an allosteric activator. So fructose 2,6 bisphosphate binds to the allosteric site of an enzyme PFK-1 and it increases the activity of PFK-1. Okay. Now, the high level of fructose increases the activity of PFK-1. Okay. The production occurs through we already have gone through this, that PFK-2 is responsible for the transformation of fructose 6 phosphate to fructose 2,6 bisphosphate. And here insulin is also there. Now understand, insulin, what happens here if we are increasing the level of insulin here? So what insulin does is it is also helps in activation of PFK-1. Okay, so it dephosphorylates PFK-2. So let me explain it. So insulin, what happens here is insulin dephosphorylates PFK-2. So it is dephosphorylating PFK-2, and by doing so, it activates its kinase activity. Okay, the kinase activity activates, which increases the fructose 2,6 bisphosphate subsequently, which ultimately increases the PFK-1. So insulin is also acting as an activator for PFK-1. Okay. Now glucagon. What happens if we increase the concentration of glucagon? It phosphorylate. So insulin was dephosphorylating PFK-2, and by doing that, it was the kinase activity which was activating, and the kinase activity was able to change or transform fructose 6 phosphate to fructose 2,6 bisphosphate. Now, what happens if we increase the glucagon level? So, glucagon phosphorylates. It phosphorylates PFK-2, which activates its phosphatase and which transforms fructose 2,6 bisphosphate to fructose 6 phosphate, like fructose 2,6 bisphosphate back to fructose 6 phosphate. So this reaction is actually decreasing the level of fructose 2,6 bisphosphate, which will ultimately decrease the level of PFK-1. Okay, because increased level of fructose 2,6 bisphosphate was necessary for the activity of PFK-1. But here the fructose 2,6 bisphosphate is transforming back to fructose 6 phosphate, which will decrease the level of fructose 2,6 bisphosphate, which will ultimately decrease the level of PFK-1. Okay. So this is the whole enzyme induction, that how sometimes there are some substrates involved which bind to the enzyme's allosteric activator site and activate the enzymes. And sometimes what if we do not want glucose to change into pyruvate, we can add some glucagon, right? And what if we want to transfer oxidize the glucose to pyruvate? We can increase the level of insulin. Thank you so much.